All right, so get this. Saturn has like a ridiculous number of moons now.
Yeah.
Forget whatever moon race you thought was going on between Jupiter and Saturn.
Okay.
Saturn just like blew past everyone.
Yeah.
274 moons.
It's incredible.
274.
It really is. I mean, it puts it in perspective.
Yeah.
You know, back in 2019, Saturn kind of nudged ahead of Jupiter. It had 82 moons.
Right.
And then Jupiter briefly took the lead in 2023 with 92.
Oh, wow.
Saturn then jumped to 146 later that same year.
Oh, wow. So
And now it's just,
back and forth.
it just exploded.
Yeah.
274 compared to Jupiter's 95.
Wow. And it's not just the number, right?
No, exactly.
It's the type of moon that we're talking about.
Right.
These aren't like the nice, regular, spherical, icy moons that we think of when we think of Saturn.
That's a really good point.
Like Enceladus.
Yeah, you have to distinguish between what we call regular
Right.
and irregular moons. So the regular Saturnian moons, the ones that people might be more familiar with, like you said, Enceladus, Titan, those are generally these spherical bodies made of ice and rock.
Right.
And they orbit Saturn in a very orderly way,
Right.
all aligned with the planet's equator.
Right.
But these new moons are a completely different story.
Yeah, it's like they just like threw a bunch of potatoes up there or something.
Yeah, they're lumpy.
And they're tiny.
Yeah, just a few miles across.
Yeah, and their orbits are wild.
Wild.
Yeah.
We're talking steep angles. Some of them even orbit in the opposite direction of Saturn's rotation.
Oh, wow.
Yeah, so it's a real cosmic free-for-all out there.
It's a mess.
And those characteristics are really key for you.
Okay.
Because those eccentric, often retrograde orbits that we talk about, meaning they orbit in the opposite direction to the planet's spin.
Right.
Their small size, that really tells us something different about their origin compared to Saturn's regular inner moons.
Okay, so why is this massive jump in the number of moons around Saturn so significant?
Well, the main theory behind this is actually pretty dramatic.
Okay.
Just picture the early Saturnian system billions of years ago.
Yeah.
It was much more chaotic.
Okay.
It was like a cosmic shooting gallery.
Right.
Larger bodies made of rock and ice wandering through the solar system would have been captured by Saturn's immense gravity.
So these weren't moons that like formed with Saturn.
No, not necessarily.
These were like travelers just passing through.
Exactly. They got snagged by Saturn's gravitational pull.
Okay, I can see that.
But here's where it gets really interesting.
Okay.
We call it a cosmic demolition derby.
All right.
So once these larger primordial moons were captured, they didn't all just settle into these stable, solitary orbits.
Right.
Over these vast stretches of time, some of them would inevitably collide with each other.
And we're not talking like little fender benders here, right? These are like high-speed impacts. Just shattering these moons.
Exactly, shattering them into countless smaller fragments.
It's a cascade of moon-on-moon violence.
Exactly. And the evidence suggests that this wasn't just a single event. This was an ongoing process that maybe even happened relatively recently in the last 100 million years.
So on a cosmic timescale,
Yeah.
basically yesterday.
Yeah, basically yesterday.
Wow. Okay, so these 128 new moons that we're talking about aren't actually like newly formed.
No.
These are remnants
Yeah.
of these ancient collisions.
They're giving us rich new detail
Yeah.
into the chaotic history.
Like pieces of a shattered vase.
Exactly.
Yeah.
And what this really tells you is that the Saturnian system we see today with the rings and the moons is not this static, unchanging picture.
Right.
It's a dynamic environment where things are constantly being reshaped by collisions and these gravitational interactions.
Nothing is permanent.
Nothing is permanent.
And, even the rings themselves are probably the result of, ancient collisions and breakups of icy bodies.
Exactly.
So it's a really turbulent past and present around Saturn.
It is.
Yeah.
And to understand this process a little bit better, we can look at what we call moon clusters.
Okay.
So, for example, you've got Phoebe.
Right.
It's a mid-sized, irregular moon.
Yeah.
With one of those eccentric backward orbits we talked about.
Right.
It's been around for billions of years,
Mm-hmm.
and it bears the scars of numerous impacts.
So this Phoebe is like they call it the lucky grandfather, right?
Yeah.
Why is it the lucky grandfather?
Well, it's managed to survive.
Okay.
Despite being heavily cratered from countless impacts over its history,
Yeah.
it hasn't been completely destroyed.
Right.
And those impacts, while they haven't destroyed Phoebe, they would have ejected a large amount of smaller debris into similar orbits.
Gotcha.
And over time, these fragments coalesced into a cluster of smaller moons that share some of the orbital characteristics with Phoebe.
So it's like a family.
Yeah, it's like a family. The largest surviving member, the grandfather, if you will, of its collisional family.
I like that. And then we've got the Mundalfari cluster.
Yes.
That seems to tell a different story.
Yes, the Mundalfari cluster is particularly interesting because it contains so many small moons.
Okay.
This abundance suggests a much more recent origin.
Okay.
You see, if these moons were really ancient over millions of years, many of them would have collided with each other and been broken down further by now.
So the fact that there are so many of them means that something happened more recently?
Relatively recently, within the last 100 million years.
Yeah.
So again, emphasizing for you that these cosmic smash-ups aren't just relics of the distant past.
Right.
This is something that's still actively shaping the Saturnian system.
Yeah.
And the fact that we're still discovering these remnants just shows how much more there is to learn about these planetary systems.
It's really amazing. And all this stuff with Saturn, it kind of makes you look at Jupiter differently, too.
Yeah.
Because I read that, everybody agrees Jupiter should have more moons
Right.
than it does now. Why is that?
Well, Jupiter is much more massive than Saturn.
Okay.
So its gravitational influence is much stronger.
Right.
In theory, it should be able to capture a greater number of passing bodies.
Right.
However, there is a key difference. Jupiter is closer to Earth,
Okay.
and its powerful gravity can make those distant, irregular satellites harder to detect.
So it's harder to see them.
It is because of the brightness
Right.
and the complexity of its gravitational environment.
Gotcha. So Saturn is further away. It's dimmer.
Right,
So
right.
it's easier to see those little irregular moons.
That's a good point.
Yeah.
But also, a key difference highlighted in the sources is that Jupiter lacks this youthful-looking moon cluster,
Right.
like the Mundalfari group around Saturn.
So that means it hasn't had a recent major moon-on-moon collision.
Exactly. At least not one that resulted in this large, observable cluster of fragments like we see with Saturn.
Right.
It seems that Saturn has been the more active participant in this cosmic demolition derby recently.
Yeah.
And one of the sources even suggests that it's unlikely that Jupiter will ever surpass Saturn's moon count through these similar collisional events.
Wow, that's kind of crazy to think about. So you have to give it up for Brett Gladman, right?
Oh, absolutely.
He's an astronomer at the University of British Columbia.
Yeah.
And he and his team are the ones who are responsible for these discoveries.
A lot of them, yeah.
And he has discovered or co-discovered more moons than anyone else.
It's pretty remarkable.
Yeah, it's hilarious.
It is a remarkable achievement. It shows the dedication and the ingenuity of these researchers.
Right.
And, as James O'Donoghue, a planetary astronomer at the University of Reading, pointed out,
Yeah.
we shouldn't lose sight of the fact that we're talking about 1 billion kilometers
Right.
from Earth to Saturn.
It's so far away.
So the fact that they can detect these small objects at that distance is a testament to the advancements in telescopes and our observation techniques.
Yeah, it's really amazing. And it makes you wonder, where do you draw the line, right?
Yeah.
What is a moon?
Right.
What is just a chunk of ice?
That is a question astronomers grapple with.
Yeah.
It generally comes down to a combination of factors.
Oh.
Size, the stability of the orbit around a planet, whether the object is gravitationally bound to it.
Right.
In this case, the International Astronomical Union has officially recognized these 128 objects as moons,
Right.
so they meet the currently accepted criteria.
Okay. But now they have this other problem, right?
They do.
They got to come up with 128 names,
Yeah, they've got to name all of them.
which is kind of crazy because
Yeah.
they have to use figures from Gallic Inuit or Norse mythology.
That's the convention.
Yeah. Paul Byrne, a planetary scientist at Washington University in St. Louis,
Yeah.
he said this is altogether too many moons.
Yeah, just imagine trying to come up with 128 unique and fitting names
Yeah.
from those specific mythologies.
Right.
It's a monumental task. It really highlights the sheer scale of this discovery.
Yeah, so it's not just some cool fact for
No.
you to tell people at a party, right?
No,
This is a huge leap forward
it really is.
in our understanding of the solar system.
These moons are providing you with this incredible window
Yep.
into the violent history of the Saturnian system.
Right.
And it shows you that these ongoing processes of collisions and the temporary nature of these celestial bodies,
Right.
even these seemingly stable moons.
It really makes you think what's going to happen next, right? We
Yeah.
see that these collisions are still happening
Yeah.
relatively recently.
Yeah.
What's Saturn's moon system going to look like a
Right.
billion years from now?
What are the rings going to look like?
Billion years from now.
Yeah, what new collisions might occur?
Yes.
What new moons might be captured?
Right.
It really does underscore the constant state of change in our cosmic neighborhood.
Yeah. It's a lot to think about.
It is.
So much more active than we realize.
It really is.
Yeah. Well, that is definitely something to ponder after this deep dive.
A lot to think about.
Yeah, thanks for joining me.
My pleasure.